Hey, so for your e-learning day today, all you have to do is follow along with the notes with me. So I told you that this schedule is tentative. It might change due to spring break coming up. But just go ahead and turn to graphing quadratic functions. We have some vocab terms that we need to know. First is we need to know what a quadratic function is. So that's our first blank, quadratic function. And feel free to pause this if I go too fast. A quadratic function it's always nonlinear, and it's going to be in this form. So typically we will see an exponent of 2 somewhere in the problem. Sometimes some terms will be missing, that's okay. You just want to make sure that you see an exponent of 2. The next vocab word is parabola. A parabola is the shape that the graph will make when you graph a quadratic function, and it's going to be symmetric. So I have a picture down here. When you graph this, it kind of has a U shape to it. That's called a parabola. So anytime it has this shape, and sometimes it might go like this, that's called a parabola. And notice it has this line going down the middle, and on each side, it's symmetric. So this side is symmetric to the right side. So the next vocab word is axis of symmetry. The axis of symmetry is that word that I was just pointing, or that line I was just pointing out. It's right here. It's the line that kind of cuts the parabola in half. It just goes straight down the middle of the graph. And then last is vertex. We've talked about vertex before with shapes, but vertex is just the point of the graph. So it's right here. If the graph looked like this, the vertex would be there. So it's always at like the tip of the graph. The vertex will also be the minimum or maximum point. So in this case, the vertex is the lowest point in the graph, so it's the minimum. If it were this graph, this would be the maximum because it's the highest point. So we're going to do some different things with this. First, we're going to graph a couple of quadratic functions by using a table of values. So we've done this before. We make a table for x and y. My pen is not working. Okay, so x, y. This time, normally I just have you do -1, 0, 1. This time, I want you to go -2, -1, 0, 1, 2. So use 5 points this time, just because there's more going on with this graph. So I'm going to use this equation and plug in my numbers. So x squared, so -2 squared plus 1. So that would be 4 plus 1, which is 5. Next, I'm going to plug in -1. So -1 squared plus 1. -1 times -1 is 1. 1 plus 1 is 2. If I plug in 0, 0 squared plus 1. 0 squared is 0. Plus 1 is 1. If I plug in 1, 1 squared plus 1. 1 squared is 1. Plus 1 is 2. And then if I plug in 2, 2 squared plus 1. 2 squared is 4. Plus 1 is 5. So notice my y values, they kind of go back to how they started. It went 5, 2, 1, 2, 5. That will happen very often because of the shape that the parabola makes. So I'm going to graph this -2, 5, -1, 2, 0, 1. I did not graph that one correctly. Okay. -1, 2 is right there. 0, 1, 1, 2, and 2, 5. Okay, so then we can connect the points. They also want me to say what the vertex is, the equation of the axis of symmetry, and the y-intercept. So the vertex, it's right here, so that's located at 0, 1. Okay, so that's an answer. The axis of symmetry, and I'm just going to call it AOS. The axis of symmetry, well, the line would go straight down the middle, so it's right here. And we always draw a dotted line just so we know that it's not actually part of the graph. This will be located at x equals 0. So since it goes through when x is 0, that's my line. It's always going to be x equals something. And then the y-intercept, well, the graph hit the y-axis right here, so that was 0, 1, just like the vertex. Okay, number 2, do the same thing, so I'm going to make a t-chart. Use -2, -1, 0, 1, and 2. If I plug in -2, we'll get -2 squared minus a -2, so be careful with that, minus 2. So -2 squared would be positive 4, minus a -2, that's plus 2 because we keep change, and minus 2. 4 plus 2 is 6, minus 2 is 4. Then I'm going to plug in -1, so -1 squared minus a -1, minus 2. -1 squared is 1, minus -1 is plus 1, then minus 2. 1 plus 1 is 2, 2 minus 2 is 0. If I plug in 0, 0 squared minus 0, minus 2. Well, 0 squared is 0, minus 0 is 0, minus 2 is -2. If I plug in 1, 1 squared minus 1, minus 2, we get 1 minus 1 minus 2, which is -2. Plug in 2, 2 squared minus 2 minus 2. 2 squared is 4, minus 2 minus 2, we get 0. Okay, so I'm going to graph this. -2, 4, -1, 0, 0, -2, 1, -2, and 2, 0. Well, that looks kind of weird. Because I know it's supposed to be symmetric, I can guess that there would be a point right here. And I can't really tell where my vertex is, but I can guess it's probably about right here. We'll talk about how to find the exact vertex here in a moment. So it's going to look something like that. So here the vertex, and I'm just going to estimate. Again, I'll tell you how to find the exact vertex in a moment. But we can estimate that the vertex is at, it looks like it's about a half and -2.5. The axis of symmetry, so the line that would be symmetric, well, it would go right here. So I'm going to draw a dotted line going down. So that's about x equals 1/2. So remember, it's always x equals something. It's always wherever it hits the x-axis. And then the y-intercept, well, that's a lot easier to tell. The y-axis is right here, so that would be 0, -2. Okay. Now, I'm actually going to stop this video because I don't want the video to run out of time. So this ends part 1 of the video, and here in a moment you're going to watch part 2.